Okay, guys, we've got our last day of the chapter, so we're continuing on with our notes packet, analyzing limits as x approaches infinity or negative infinity when you're not looking at a graph. So these aren't rational functions where you have like vertical asymptotes and horizontal asymptotes and stuff. So again, I want to recall some info from Algebra 2. Do you remember what a function that has a positive x to the third, do you remember what the shape of that looks like? So a positive x to the third. So I'm finding like my degree of this polynomial is 3. Remember, that means the highest exponent on x. So it's a cubic polynomial. It's a cubic function, and it has a positive lead coefficient. So what you should remember about what that looks like in terms of the graph in Algebra 2 is that it looks kind of like a snake thing. And your left hand is down and your right hand is up. Okay, yeah, there's a little bit more to it than that when you actually learned how to graph this stuff in Algebra 2, but I just want you to remember the shape, and then I'm going to show you a shortcut on how to evaluate these limits. And so if you think about this, the limit as x approaches infinity, so as the x value goes to the right forever, what that means is your right hand. What is your right hand doing if you were making this graph? My left hand is down and my right hand is up. What is up forever in terms of limits? Equals infinity. So as the x value goes to the right forever, my y value skyrockets. So as x increases, the y value goes up forever, which is positive infinity. Let me show you a shortcut on how to figure this out. What you want to do is you want to figure out that x to the third. That's called like the dominant term in this polynomial because it has the degree of 3. And as x approaches positive infinity, what I want you to do is take a positive number and raise it to the third. Positive because it's positive infinity. What does that give you, positive or negative? Any positive number raised to the third power, does that give you a positive answer or a negative answer? It gives you a positive answer. That's why we get positive infinity. So you can think about it in terms of what does the shape of the graph look like. If you're not so cool with shapes of graphs and Algebra 2 stuff, you can do this shortcut. You can take a positive number because x is approaching positive infinity and raise it to the third power because this is a cubic polynomial. Any positive number you want, when you raise it to the third, it gives you a positive answer. Therefore, our positive infinity is the limit. Let's try another one. So again, I'm going to talk about in terms of what this function looks like. This is another positive x to the third function. So Algebra 2 review, that means it looks something like this. And again, what is my left hand doing here? This is x approaches negative infinity. So as x goes to the left forever, so these are the negative x values if I'm looking at this whole snake-looking function. What is your left hand doing? It's going down forever. Therefore, my answer is negative infinity. How can I do that with the shortcut? Again, I'm going to take this x to the third, and in this case, I'm raising a negative number because it's negative infinity, and I'm raising it to the third. What happens when you take a negative number and raise it to the third power? It gives you a negative answer, right? So again, my answer is negative infinity. That's how the shortcut works. Let's try a couple more. In this case, this is a x to the fifth graph. So that means my degree of this function is x to the fifth. So my lead coefficient is -2, and it's raised to the fifth. A negative odd exponent, what this graph looks like, actually starts up and goes down and has a couple humps. You don't have to worry about the humps. That's all Algebra 2 stuff. But this is what the shape of this x to the fifth graph looks like, and it has a negative exponent. So negative lines start up and go down. They have a negative slope. Negative cubic functions like a and b were both positive cubic functions. If I would put a negative sign in front of that, that would flip it upside down and it would still have this shape where it's going down. Negative x to the fifth graphs look like this also. Again, if this is kind of confusing to you, you don't really have to care what the graph looks like, but I think it might help recall some knowledge from Algebra 2 to help you think through these limits. We can work with the shortcut also. I'll show you that in a second. But again, here, as x is approaching positive infinity, that means my right hand, my left hand is up in the air, and my right hand is down. That means that the limit is negative infinity. What is your right hand, because x is getting bigger, doing? It's approaching negative infinity. Let's try it with the shortcut. I'm just going to take this entire term, keep the -2 with it. And what kind of a number am I plugging in? I'm plugging in a positive number because the x is approaching positive infinity. So I'm going to write a positive number in here. What happens when you take a positive number and raise it to the 5th power? It stays positive. But then when you multiply it by -2, because that's the lead coefficient here, we end up with negative number. So negative infinity. So the shortcut works, or you can think about what the shape of the graph looks like. Let's talk about this one. Oh, everybody should know what this graph looks like. 4x squared. It's a positive parabola. Looks like so. So in this term, what is my left hand doing? Because it's negative infinity, so as the x value gets smaller and smaller, the left-hand side of the graph, what's your right hand doing? Or your left hand, excuse me. The left hand here is approaching positive infinity. So again, x approaches negative infinity means the left-hand side. What is your left hand doing if you were making the shape of the parabola with both your hands? Left hand up, right hand up. That means that the limit, the y value, is getting higher and higher and higher, approaches infinity. Let's try it with the shortcut. I'm going to take this whole lead coefficient term. I'm going to plug in a negative number here. When you take a negative number because it's approaching negative infinity, any negative number squared becomes positive, and then when you multiply it by 4, it stays positive. So I get a positive number. My answer is positive infinity. Okay, so shortcut as well as a little bit of connection to Algebra 2 there. I'll have you copy a couple things down here. So again, this is some more review and some stuff that we've been kind of talking about in the last couple sections to begin with. Just remember what happens when the degree on top, so now we're looking at rational functions here. So we have something on the top and something on the bottom. So how do we do that to evaluate these limits without having to graph them? There are, some shortcuts and some things that we can do like we did above. You don't have to graph all of this stuff. If it's a really simple graph to do, like the ones we did earlier in the chapter, then for sure, graph it, and that'll make you feel really confident about your answer. But in this case, this is a little bit more complicated, so we can use our shortcut. Just a couple things to remember. If the degree of the numerator is less than the degree of the denominator, that means your horizontal asymptote is y equals 0. Just remember that. We've already talked about that. What happens when the degrees are equal on the top and the bottom? Then you take the lead coefficient of the numerator and divide it by the lead coefficient of the denominator. And then what happens if the degree on the top is greater than the degree on the bottom? That means you don't have a horizontal asymptote. It's actually a slant or an oblique asymptote. That was some more Algebra 2 stuff that you guys did last year. But that's when we're going to plug in a positive or negative number, kind of like we did earlier in this video. So I'll show you what that means when we go through a couple of these examples. So this very first example I'm looking at, in this case, we have the degree on the top is 1 and the degree on the top is 2. So that means we're in scenario number 1 above. This means the degree on the top is less than the degree on the bottom. That means my horizontal asymptote is y equals 0. And that is because the degree on the top is less than the degree on the bottom. That means that the limit is 0. So remember when we were to graph these things, that means that it's approaching a certain y value. So in this case, my graph is not approaching, like it's not skyrocketing or going down forever. It's actually getting really, 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 really close to 0. That's what the horizontal asymptote is. And that's how we're going to take that stuff into account when we do these rational functions. Let's see, this one we have degree on top is greater than the degree on the bottom, so that puts us into scenario 3 up above. So what we're going to have to do here is I'm going to take my leading term, what I highlighted there, just like we did above, and the leading term of the denominator, and what I'm plugging in here is a positive number because x is approaching positive infinity. So if I put a positive number here and a positive number here, I'm just trying to analyze whether this answer is going to be positive or negative. So a positive number to the third is still positive, and when you multiply it by 3, it's still positive. And the same thing on the denominator, a positive number squared is still a positive number. Therefore, my answer is positive infinity. Let's look at letter C. In this case, I have the degree on the top is equal to the degree on the bottom. And so remember, that means that the horizontal asymptote is the lead coefficient, which is 7, over the lead coefficient, which is -4. And that is what my limit equals. If I were to graph this, as x approaches infinity, my right hand would be really, really, really close to the horizontal asymptote. It gets really close to -7/4. Let's try letter D. In this case, I have another one where the degree on the top is greater than the degree on the bottom. And so what I'm going to have to do is I'm going to have to take those lead coefficient or lead terms. This is everything that I have in highlighted in green. So this goes here and this goes here. And in this case, I'm plugging in a negative number because x is approaching negative infinity. So what happens when I plug in a negative number here and a negative number here? So I'm going to analyze these. When I take a negative number and raise it to the third, it stays negative. And then when I multiply it by 3, it is still negative. So I get a negative number on the top. What about when I take a negative number and square it? It becomes positive. A negative number divided by a positive number is a negative. Therefore, my answer is negative infinity. Okay, a couple more, and I'm sure you guys are getting the hang of this already. But again, remember the whole purpose of doing this little shortcut thing is because I don't really want to have to graph this and this. I don't know what that graph looks like. If I don't have a calculator, that would be almost impossible to graph very quickly and come up with an answer as the limit approaches, as x approaches negative infinity. So that's why we have these shortcuts. So just something to point out here, remember that the degree on the top here is 2, but the degree on the bottom here is 3. So just be careful. Sometimes they could write these out of order. They're always supposed to be in descending order, and just the highest exponent, no matter where it is what the degree is. So in this case, we're scenario number 1. This means the horizontal asymptote is y equals 0, and that means that the limit is 0. So really quick one, but just wanted to point out, sometimes they rearrange the terms in either the numerator or the denominator. You need to be really careful in how you're picking your lead coefficients and your terms for the degrees. Okay, let's look at F. Let's see, we've got 5x to the third on top and regular x to the third on the bottom. So the degree on top is equal to the degree on the bottom, so that's scenario number 2 from above. That means that my horizontal asymptote is y equals the lead coefficient of the numerator, which is 5, and the lead coefficient of the denominator, which is 5. And in that case, as x approaches negative infinity, my limit is 5. So basically, you don't really do anything with this negative infinity or positive infinity, if that's what it is in the question. If it's scenario 1 or 2, because your answer is either going to be 0 if it's scenario 1, or it's going to be whatever the limit is, the lead coefficients, if you're in scenario number 2. The only time you use this positive or negative infinity is scenario number 3. And that comes in the next example. So the next example is another scenario number 3. So my degree of the numerator is 3, but my degree of the denominator is only 2. So that's scenario number 3 that we wrote above. That's when I'm going to use this infinity or negative infinity in this case. So what I'm going to do is I'm going to take my lead coefficient, which is -1, and the numerator is raised to the third. The denominator is squared. And in this case, what I'm plugging in is a negative number because x is approaching negative infinity. So a negative number goes in here, and a negative number goes in here. So now we just have to think positive and negative sense, I guess. So when you take a negative number and raise it to the third, it stays negative, and then when you make a double negative there, it actually turns to a positive. So my numerator is positive. When I take a negative number and square it, it is also positive. That means my limit is positive infinity. Okay, and then we've got one more, which is another scenario number 3. In this case, we have x squared in the numerator and just regular x in the denominator. Again, remember they reordered those. Just beware, you know how to pick what the degree is of the numerator and the denominator. In this case, I am In scenario number 3, degree of the top is greater than degree of the bottom, so I'm taking the lead coefficient, which is just 1 for the numerator, and the denominator is -3 times something. Okay, so this is everything I have highlighted in green, as you can see. And in this case, x is approaching positive infinity, so I need to just take a positive number and plug it into both of these parentheses. And in this case, a positive number raised to the second exponent, positive number squared, is positive. When I take a positive number to the first exponent, it's positive, but when I multiply it by -3, it becomes negative. Therefore, a positive number divided by a negative number leads me to negative infinity. Okay. Something cool that you might want to do if you have a graphing calculator is you can actually type any of these functions in. You can like type this into y equals and hit graph and just see what it looks like. If you are going to do that, just make sure you put parentheses around the numerator and parentheses around the denominator so your calculator knows it's a rational function. And you can actually look at what is my right hand doing depending on what this graph looks like. These graphs are all pretty complicated, which is why I didn't graph any of them. But if you have a graphing calculator, you can take a look at it. Graph this in y equals divided by this. And your right hand is going to be going down forever for this one. That's why this shortcut is pretty cool. And you don't have to worry about really complicated rational function graphs. You can just do the shortcut and still analyze the limit. I'm going to skip that last example. It doesn't fall into our curriculum for this year. So that concludes the chapter, you guys. You can go ahead and get started on worksheets and make sure you email me or your teacher if you have any questions, okay? Thanks for watching and have a great rest of your day.